All right, guys, so today we're going to look at implicit differentiation. Hopefully you've watched the videos already. And what I want to do today here in class is actually explain to you what the point is of this whole implicit differentiation thing. So it says find the equation of the tangent line / lines for the curve x to the fourth equals 16x squared minus 16y squared when x is equal to 2, which, by the way, is very similar to the warm-up question we talked about, writing the, how do we write the equation of a tangent line, right? The equation of a tangent line. Well, to write the equation of a tangent line, we need to know what x is, we need to know what y is, and we need to know what the slope is of all of that stuff, right? Okay, so that's what we're going to do here. The problem is, let's see if I've got my curve here. I need to fix this curve. I'm going to go ahead and type this curve in here, which I think, what was that again? Was it x to the fourth?
Yeah.
Equals
16x
squared
minus 16y
minus
squared.
16y squared, right?
Yeah. Oh,
that's neat.
never seen that before.
Oh, I remember.
Now here's the thing. You might be thinking, wait a minute, whoa, Mr. Allen. We just talked about like our quiz, right? We just talked about our quiz number 2, which I think I just closed. Oh shoot, I wish I hadn't done that. But everything was y equals this, f of x equals that. Whenever you have something written like, y equals the square root of 2x, we call this explicit. This is explicitly written. Or f of x equals sine squared x. Explicitly it's written that y is equal to this, y is equal to that. This equation is written implicitly. Notice it doesn't have y by itself. It doesn't even have x by itself. Now be nice, even though this graph is crazy, be nice if calculus worked on it too, wouldn't it? So it turns out that it does work, and I'm going to show you how to get that, hopefully. By the way, what was x in this problem?
2.
X is 2, so we know what that is, so I'll change that to 2. Do we know what y is?
No.
Can we just pretend that we know what it is?
Sure.
By the way, how would you find y?
Plug it in.
You would plug 2 in here for x, okay? And I'm just going to kind of cheat here to save us some time. I'm telling you that it's going to be the square root of 3, but more importantly, it's actually going to be plus or minus the square root of 3. Now, if you don't believe me, I encourage you to check, but I'll just show you kind of why that has to be true. Right here is when x is equal to 2, correct?
Yeah.
How many points are on the graph when x is equal to 2?
2.
There are 2. This point here turns out to be 2 comma square root of 3. Can you guess what this one is?
2 comma negative square.
Negative square root of 3. Does that make sense?
Yeah.
Oh, by the way, that's the other interesting thing about what we're doing here with this implicit differentiation. Sometimes we're not even doing calculus on functions. That's not even a function, right?
Oh, yeah.
Doesn't pass the vertical line test, does it?
No.
But we can still do calculus. So far we got this. Now we got to figure out the slope of the tangent line, which is the calculus step, right? And we just talked about what derivatives are on our quiz that we just went over. But I'm going to show you how to do this one implicitly. So what we're going to do is this. We're going to do the derivative with respect to x of all of the stuff on the right side and the left side. So I'm going to write this in blue. And then the stuff that we're doing this to in red, right? That's 2. Okay. Make sense? Okay. So we can do this. What is the derivative of x to the fourth?
4.
Yep. We're not going to do the limit definition because Mr. Allen taught us the shortcut. That's 4x to the third, right?
Yeah.
Okay. What's the derivative of this?
32.
Well, that'd be 32x. Now, I'm going to leave the next part in blue, okay? Because this is the part that gets a little tricky. In fact, this is the only part you need to be extra concerned about. If I'm doing my derivative with respect to x, which is what we do most of the time in this class, and the thing I'm trying to do the derivative of is in terms of x, we just do like we've always done. Here's the only time we do something different. We're trying to do the derivative with respect to x, but this is in terms of y. So here's what you do. By the way, what do you think the answer is?
32 times 100.
32. Y is correct, but now I'm going to write this in green. We also have to include, this. Now let me explain why that is. If I'm doing this derivative with respect to x, think about the chain rule with this, right? If you did the derivative of x to the fourth, you'd take 4 to the front, you change the 4 to a 3, and then you'd leave the inside alone, leave the x alone, correct? What's the derivative of x, though? It's 1, correct? So if I take this times 1, guess what you get? 4x to the third, right? Same thing here. If I do the chain rule with this, I take the 2 times the 30, or 2 times 16, that's 32, subtract 1 from the power, I get 1, and then what's the derivative of x? So here's the catch. You do the exact same thing here, and I guess what I'm trying to say is we're using the chain rule. What is the derivative of 16 something to the second? Well, it's 32 something to the first times the derivative of the inside. What is the derivative of the inside? It's dy dx. And by the way, if you don't like writing dy dx, you could also write y prime. It doesn't matter. I'm going to write dy dx. Is that okay? Okay. So far, by the way, I'm done with the calculus now in this particular problem. Now my goal is to get dy dx by itself. Okay? So what I can do is, would you guys agree I could move this whole thing over here?
Yeah.
So that'd make it 32y dy dx. In fact, here, let me leave that in green. Let's leave this guy here in green. Make it stick out here because that's the part that's different, right? Now, I'm going to leave this guy right here, 32. Did I mention I don't feel like I'm doing great today? Where's this guy going to go? It's going to go over there, right? So that makes it
Negative
minus. Now I'm almost there.
Divide by the 32.
Oh, not 32, it's 32.
Why?
I left the y out
Yeah.
there, sorry guys. There should be a y there. So that tells me that dy dx is equal to 32x minus 4x to the third over 32y. And that's the derivative. Now you can clean that up a little bit, right? Would you agree we could divide through by 4?
Yeah.
4 goes into 32.
8.
Right. So this could be thought of as 8x minus x to the third over 8y. Can I factor out an x there if I wanted to? Yep. You don't have to do this step, but I'm just going to make it look really clean. This is my dy dx. In fact, if this was a test question, this is probably how it'd be written. Okay, so did I figure out what my slope was yet? Nope, I found the derivative. The derivative will give me the slope, but what do I have to do to find the actual slope when x is equal to 2 and y is equal to we got 2y, so we'll just do the positive one first. What do I got to plug into here? Yeah. Can we do the positive one first? I'm going to do x equals 2 and y equals the square root of 3. Can we go ahead and do that?
Yeah.
Okay, so let's go and do that now. So now I'm going to say that the slope is equal to 2 parentheses 8 minus 2 squared over 8 times the square root of 3. What do you get on the top there? I think you get 8, don't you?
Yeah.
And what happens to the 8 over the 8? So what are you left with?
1 over the square root of 3.
1 over the square root of 3. Or you guys are probably more comfortable writing it that way, right? Square root of 3 over 3.
Of course.
So what's x? 2. What was y? Square root of 3. What was the slope of the tangent line? Square root of 3 over 3, right?
Yeah.
Okay, remember all that stuff because I'm going to go back to that picture. This is where the videos hopefully can hear me. I am now going to write that equation of the tangent line. I think we said that y was the square root of 3, correct?
Yeah.
So I did literally type in square root of 3 into Desmos equals, and then I think we said the slope was the square root of 3 divided by 3, right? And then what did we say x was?
2.
Oh, shoot.
X was 2, y was the square root of 3, the slope of the tangent line is square root of 3 over 3. You tell me, does that look like a pretty good tangent line right here?
Yeah.
Can you guess what this tangent line down here is going to be? What's going to change over here? Is this minus square root of 3 going to change?
Yes.
It'll become
Positive.
positive. Is this slope going to change?
Yes.
Can you guess what it's going to be?
Negative.
Negative. Is this 2 going to change?
No.
Okay, so let me type that one in. I think you said plus. And then the x stays minus 2, right?
Yeah.
I forgot to put negative slope in. Didn't you guys say negative slope?
Silly goose.
You okay now?
Yeah. And it crosses.
Isn't that cool? Now, a couple of comments. I just heard someone say, hey, Mr. Allen, notice these tangent lines kind of hit the curve over here. That's true. Guys, the point of tangency is right here. So the curve is tangent, or the line is tangent to the curve at this point. Just because it's tangent doesn't mean that it won't hit it in some other place. In fact, most of the time it does hit it in other places. If you think about really any curve, if you drew a curve like this, right, and you drew a tangent line here, it's gonna have to hit over here too, right? So don't let that disrupt you. Does that make sense?
Yeah.
Okay. So I'm gonna stop this.